We invited Ken out here to talk about what's real and what's not real, what you can do. And with that, I'll give you Ken. He's worked for very large data centers like Rackspace and now at Rubrik. So please give Ken your attention. Thanks.
Hey, thanks, everyone. And I appreciate Chris and Don for inviting me to share with you guys today a bit. So we are going to talk about the software-defined data center. Is there anyone in this audience who has never heard the term software-defined data center? One. Like one guy there who sells software-defined data center has never heard of it. So, all right, great. So as Chris mentioned, you've probably heard a lot of stuff. You've heard a lot of marketing. You might have seen some things that make you get excited about software-defined data center. So what I want to do today is we want to kind of separate things a little bit, try to figure out where the hype is and where the actual reality is, or where I'm going to stop saying software-defined data center because it's too long. I'm just going to call it SDDC. So that's the shorthand. So what we're going to do actually is we're going to run through a couple of things. One is we're going to start talking about what is some of the hype that you're hearing today about this whole SDDC stuff. And then because I think it's really important to have context when we're talking about a new technology like this, is I want to kind of give a quick historical survey of the past 10 years. Kind of where the terms software-defined data center came from and what it meant then versus maybe what it means now. And then we're actually going to talk, based on that historical context, we're going to talk about I'm just going to give some characteristics, define some things I think make up what is really in SDDC and why it should matter to you as an end user. Okay, and then I want to kind of do a survey of all the various vendors out there who are claiming to have software-defined data center and map it to the characteristics that we talk about and kind of talk about how real is this thing that they're pitching to you. And then finally, I want to share some ways you guys can get started. If you want to learn more about this, if you want to start playing around with it, there are ways you can start playing around with this whole concept of SDDC. So a little bit about myself first. My name is Kenneth Hoy. I'm a technical marketing engineer. And you can follow me on Twitter here if you want to talk afterwards. And also there are a couple of places where I blog about various things related to IT, including SDDC and cloud computing. So a couple of other things background-wise and why I'm here talking about this whole technology to you is, so I worked at various places besides where I am now. I actually was at a company called VCE. Some of you might have heard of them. Back when they were selling what they, at that time, called cloud in a box, and then eventually called the software-defined data center in a box. And then I also worked at EMC for a time at a group that created what they called the EMC Hybrid Cloud. Where I was involved in the team that created one of the worst named products in the entire world. I think it was called the EMC Hybrid Cloud Software-Defined Data Center Edition. So you try to be a sales guy and put that in a deck and make it look cool and sexy. Not very easy to do. And since then, I've also worked at places like Rackspace, where I've worked on things like OpenStack, worked on a bunch of open source projects, as well as and currently, today I'm focused mainly around the public cloud, AWS, Google Cloud, and Azure. So I've kind of touched a lot of different vendors and places where a SDDC actually makes sense and where it's been instantiated in some manner. So let's talk a little bit about some of the hype for some of the reality. So how many of you are vendors in here? One or two? OK, so when you hear me go through this presentation, this is probably what you're going to think of. And the way I look at it is if I do my job right in this session, 20% of you will be completely pissed off by what I have to say. Another 20% of you will think that I'm overhyping SDDC. And then the other 60% will go, this is actually a fair presentation. So that's the hope. So if you read anything in the IT press, you'll see that this whole idea is that software-defined is the future, right? How many of you read Gartner stuff? No one? OK, so very few of you actually will announce that you do, but all of you will tell. privately will tell me my manager won't move to any new technology until Gartner blesses it. So 3 years ago, Gartner said, look, the future is software-defined data centers, right? By 2020, almost everyone will only be deploying SDDCs. So that's obviously a very optimistic view. And obviously, VMware has a vested interest in SDDC. And they'll tell you that 3 years ago, we already created the SDDC's data center. It's there. You could have, I don't know how many of you knew this, but according to VMware, you could have deployed it 3 years ago in your data center. But the reality is, when I talked to some people and I said, hey, what do you guys think SDDC is and how real is it? This is probably the most typical response I get, right? It's just a marketing term. It really doesn't mean anything, right? Sometimes I've also gotten a little more developed response, this idea that SDDC is not only hype, but is actually just a way for vendors to sell you something so that you think you're competing with the cloud vendors, when actually all they've got is the same old stuff cobbled together. And then others who have some experience in this will tell you, you know what, no one can tell you that SDDC is something you can buy in a box and easily deploy. It's something that requires a lot of work and requires a lot of changes in how you do IT in your environment. But overall, I think what I sense is a lot of people are frustration. Like if everything that a vendor sells you is software-defined, is there anything that's not software-defined? Does that even mean anything? Right? If that storage array that you bought 5 years ago or 10 years ago has been software-defined 10 years ago, but they only told you about it 2 years ago, does software-defined data center mean anything at all? And then some other people would say, I think a fairly balanced view, which is one that you'll probably pick up that I'm going to talk about, is a lot of vendors, including VMware, has a vision for SDDC, but really are only now starting to deliver on it. And that what they talked about 3 years ago probably wasn't a software-defined data center. It was something it was a vision they were pitching that they were hoping to get to at some point. All right, so let's go through a quick historical survey about where the whole idea of software-defined data center come from, the term, and some of the characteristics and benefits with it. So I'm going to start with networking. So I'm sure some of you will go, well, what about vSphere? Isn't that software-defined computing? Well, I'm going to pick networking mainly because that is actually where the term and some of the key core benefits that come with SDDC actually came about. And as you can see, in any technology that we have today, there's a long tail, right? SDDC isn't something that just happened in the last 10 years, really. It's something that's been building for over 20 years. And in some cases, some people would argue probably since the beginning of computing. But software-defined networking itself, really, it's kind of the forerunner for what you hear today about SDDC. And in particular, 2008 was a very important year for this particular segment of the industry. So how many of you have heard of Nicira? Most of you, if you guys use VMware, you should have, because Nicira is the company that basically that VMware purchased, and their product is now what is the underpinning for NSX. So back in 2008, an engineer that some of you might have heard of, Mon Casado, was at Stanford working on an open source project called OpenFlow, which was supposed to change the way that networking was done, how networking traffic would be managed. And shortly after OpenFlow came out of Stanford, he left and formed a company called Nicira, which introduced further versions, tried to productize OpenFlow, and also created something called the network operating system, which was the idea of let's have an operating system for your network that isn't just for a switch, but is actually a network operating system for your entire network, for all the devices. And it was in that introduction of OpenFlow that the term software-defined networking actually was first popularized. So you can, in essence, trace back the whole idea of SDDC to 2008 when OpenFlow was announced by Stanford, by Mon Casado. So shortly after that, we started seeing SDN, or software-defined networking, in the real world, beginning with the Open Networking Foundation, which is a like an open, basically a conglomerate of vendors came together, formed a foundation that would kind of shepherd the whole SDN initiative, including things like OpenFlow and ONOS, which is kind of the predecessor to a network operating system. And around that time, you started also seeing SDN kind of in production, in the wild, right? So Nicira kind of led the way, which is, again, why VMware bought them, right? They introduced what became NSX, started with Open vSwitch, OpenFlow, the network virtualization platform that is now currently called NSX. And then around that same time, companies like Google, like Facebook, started talking openly about how they were building their own software-defined networks using OpenFlow as kind of the foundation. And then the public cloud providers, in order to try to differentiate themselves, started talking about how they were building software-defined networks, using some cases OpenFlow, in other cases using software that they had developed in-house. And then, of course, it wasn't long before other vendors kind of jumped in, VMware buying Nicira to release NSX, and then Juniper and Cisco also got into the act, right, to announce their own software SDN products. So obviously there was a lot of excitement around SDN, and people started asking, well, what is this thing? Outside even the networking community, they started asking, what is this thing? What's so exciting about SDN? So there are a bunch of things you can say about it. I think the core, if you distill it down to the core, the big insight with SDN, and you'll see this kind of as a theme that will go through all of the components of the SDDC, is this idea of being able to separate the data plane from the control plane, right? Separating what actually does the compute processing or does the flow of traffic from the management plane that actually programs it. So data plane, in this case, obviously controlling what forwards are packaging, but really the most important thing was being able to take that control plane out of a switch, put it somewhere where you can actually manage multiple switches. Some cases a single management plane, in other cases, basically a distributed control plane that could manage an entire network and program what it does. And the big thing there was being able to, finally getting an end-to-end view of the entire network, right? Not just have to go into individual switches to see what's going on, but getting an entire view of everything that's going on in your network. Being able to have a single point where you can say, I'm going to change the way, I'm going to change firewall rules, I'm going to change the way certain flows work from one single place and then be able to send it out to an entire network of devices. That was kind of revolutionary if you think about it in the way, because not only did it save time, but it was also made the network much more adaptive and much more flexible. So why SDN? So some of the benefits, again, we talked about centralized management, not having to manage one switch at a time. This idea of being able to program things. So if you can program things, now all of a sudden, instead of having to change things manually every time, you can actually set rules and policies and say, based on certain types of traffic, switches will automatically, or the control plane will automatically tell its data plane devices to change the way they do flows and change the way traffic is shaped and moved. Right, so making it very adaptive, making it very agile, right? Instead of having to wait a week to have a change in the networking, now things can be done dynamically. Right? And the idea of open standards was a big part of SDN, that no one vendor should own what SDN means and what SDN can do. And for a lot of people, this was a really big thing, this idea that now if I'm not actually embedding all the software, these control plane capabilities into the silicon, I can actually run it on standard x86 hardware, right? Instead of having to buy these very expensive switches. So, and a couple of primary use cases that came out of SDN was network virtualization and network function virtualization. So these are concepts that today are often conflated with SDN, but actually they're different. In fact, this idea of having these virtual networks that can go back, that you can change on the fly, or being able to set up these virtualized firewalls whenever you need, these things were in development before there was an SDN, before OpenFlow came about. What SDN did was it made it more possible because of this ability to be able to program from a single point of management, it actually enabled these things to happen. So that's why sometimes they get conflated together, but actually they're separate. So we spend a lot of time there. So let me go back. So some of these benefits, you're going to see them repeated in some of the other use cases I talked about, so kind of keep them in mind a little bit. But I want to talk about storage, because storage people had to get into the act, right? They couldn't just have networking have all the fun. So interestingly enough, the beginning of talking about this concept of software-defined storage was probably in 2012, when VMware talked about the VMware Software-Defined Data Center. And in that talk that I'll reference later, Steve Harris talks about that a core component of the software-defined data center that VMware was going to be rolling out is software-defined storage. And obviously, people really glom onto that. And magically, within a year, every storage vendor had software-defined storage, right? Because that's a great way to sell product. But where things really started to get moving, where you started seeing some things that looked like could be software-defined storage, was in 2013. How many of you have heard of EMC Viper? Okay, some of you. So this was I was actually at EMC at the time when we open sourced this. As an aside, this is probably a great use case for how a legacy vendor should not do open source. Because today, Viper is essentially a dead project, because they couldn't get any traction. But there was this whole idea that there was going to be a control plane that could manage your storage, whether it was EMC, NetApp, whether it was white box storage, anything that could that APIs that could talk to a control plane, the control plane would be able to manage. So they tried to get that out. No one wanted it, as it turned out. Or storage vendors couldn't agree that they would want to work with Viper. And then that same year, VMware announced virtual vSAN, what's called vSAN, or virtual SAN, which is now called vSAN. And that obviously became one of the core components of the VMware SDDC. Then in 2014, how many of you heard the Storage Networking Industry Association had to jump into the act, right? Because they didn't want to be left out. So they came up with their definition of software-defined storage, came out with a couple of standards for how you could manage such an environment. And then Red Hat said, you know what? Let's do some open source stuff with software-defined storage. So they brought into or productized Ceph and Gluster, which were these open source storage software, and proudly proclaim that we now have software-defined storage that is open source and available. So this is SNEA's definition. You don't have to read it. It's long. The main thing there is this. The two main concepts they had was that you should be able to pool all your storage, no matter where it's from. So you see it as a single storage thing, and that there would be a service, what they call a service management interface. Essentially, if you break it down, it really comes down to you should have a data plane. That data plane should be either commodity or heterogeneous storage hardware, and then you should have a control plane that you can use to program that data plane, right? Very similar, again, to the concept of SDN. And then all that would bring things like automation and scalability and adaptability. So a couple of things so despite that definition, if you would ask your storage vendors, what is SDS? The answer is it depends on who the storage vendor is. So sometimes it's just virtualization. You know, I've talked to some storage vendors that said, we've been doing software-defined storage since the 1980s, right? You have a virtual LUN. That's as software-defined as you can get, right? Also, some people say it's storage management, right? If I can manage not only my array, but some other vendors' array, that's software-defined storage, right? Some people would say it's a virtual storage appliance. That's it. That's software-defined. It's all software, right? And then kind of similar to that, this idea, if I can run my storage software on x86 commodity hardware, that's software-defined. And finally, separating out the services. So if you look at this definition, if this was really the definition for software-defined storage, how many of you own software-defined storage systems today? all of you. So really, so my contention is going to be of all the components of software-defined anything, software-defined storage is the least complete. It's the least developed, and it's probably the most BS of any of the components. And the reality is, and I know I'm sounding a little harsh, I think the reality is, one, storage is hard, right? Trying to make sure your data gets protected and gets to the right place is not easy. And second, having been in the storage industry for a long time, that is probably the most contentious group of people of industry of any of the others. And there's a reason for that. If you think about it, is there anyone who disputes that VMware owns virtually the entire compute virtualization market? Probably no one. Is there anyone who would dispute that, for the most part, Cisco has and still dominates networking? Probably very few. Who dominates storage? Right? Storage is that one part of your data center where you can be the dominant player and have less than 50% of the market. So what that creates is a lot of people who come in and go, you know what? If there's no dominant player here, I can get my share, and I don't want to work with that guy. So that unfortunately creates an atmosphere where very few storage vendors want to work together to create software-defined storage, because they feel like that would level the playing field too much and would take away their opportunity to be the dominant player. All right, so some of the stated, that being said, there's still some benefits, especially if you take the SNEER definitions and separate the data and the control planes. Right? Again, centralized management, this idea that I treat my data plane as a thing that I can manage using my control plane, no matter what the data plane is, so any storage array. Again, commodity hardware, adaptability, right? Being able to dynamically allocate storage as I need it. And again, you pick this up. A lot of this is the same things that you saw as a benefit to SDN. And it's all, again, related to this idea of being able to separate out the control and the data. All right. So now finally get into the SDDC. So you can trace this back. The first instance of SDDC mentioned was probably in Interop 2012. Steve Harrod, CTO of VMware at the time, had a keynote and said, we are announcing that VMware is building out the software-defined data center for the enterprise, and that they will be coming out with a suite of products and an integrated solution for doing that. And he talked about the fact that obviously it's going to be built, this is VMware, right? They're not going to say we built it on physical. It's going to be built on virtualization, and there's good reasons for that, right? And it's going to be commodity hardware, right? At the time they knew vSAN was going to be coming out, and that you could use that in white boxes. They haven't announced it yet, but they wanted a solution that you could run anywhere on any x86 hardware, right? This would be something where you don't have to, so the idea of declarative is instead of having to click through a bunch of different steps, you should be able to just say, I want this configuration, and the SDDC would auto-magically create that configuration for you across compute, network, and storage. So right, application awareness, and most of this is focused around what they saw in the announcement on storage, which is this idea of the storage volume would be allocated dynamically according to the needs of the application. So that was what they were hoping. Again, a vision, right, of what they wanted to do. And the way that Harrod phrased it was, this is stuff that's already been running in places like Google and Facebook. We're going to bring it to the enterprise. So you can get all the benefits, right, of SDDC that the hyperscalers have. We're going to bring it to you in the enterprise. I'm going to talk a bit more about that later. So we just went through that quick. So you just went through 10 years of history in like probably 20, 30 minutes. Yeah, in about 25 minutes. So let's try to break this. Let's try to consolidate things a bit and talk about what is, based on what we said, what is the software-defined data center? So I'm going to start with what it isn't, right? Because, again, you're going to hear a lot of people are claiming they have SD something. And, putting a horn on a horse doesn't make it a unicorn. Calling something software-defined doesn't make it software-defined. So first of all, it's not virtualization, right? Sorry to say, a lot of people sometimes think that's the software-defined data center. It's really just my VMware stack. It was the same problem we had with private clouds. I remember I had a customer who was able to deploy a private cloud in 1 week. And the way they did that was they changed all the documentation to say that VMware stack we used to have is now a private cloud. So you still get, and you're getting a lot of that with SDDC, right? I have a VMware, I have a vSphere stack, I have a Hyper-V stack, or even a Red Hat stack. And so I must have software defined. But if you look, so I'll talk about later, you'll see that that alone doesn't have a lot of the characteristics that we've actually been talking about in our survey. Right? And it's not just software running commodity hardware. The reality is, how many vendors today run things on their software on specialized silicon? Very few. Almost everyone's running on x86. Right? So just being able to run on x86 doesn't make you software defined. And also, a lot of hyperconverged vendors will tell you, look, my software runs on this one box. It must be software defined. That also is not software defined because, again, it's missing some of the characteristics that make software defined software defined. So what is it? So here's the thing that I wanted you to think about. There's actually two perspectives. There's a user's perspective, and then there is an operator or an admin, IT admin perspective. And sometimes we conflate them or we ignore one over the other. But actually, there's two views, right? So what does a user want from a software-defined data center? So first of all, have any of you ever talked to a developer or an end user that said, I want software-defined data center? No one, right? Because they don't care, right? That's the details they don't want to have to worry about. All they want is an outcome. And this is the outcome, right? They want IT. They want it to be as a service, right? They don't want to have to go through a lot of hoops just to get a VM or get a development environment, right? They want it to go fast, right? They want it yesterday. They want on demand. They want it self-service, right? They don't want to have to go through IT again if they don't have to, right? And they want to be able to scale up and down. They want to say, if I need 5 VMs today and then 100 VMs 30 an hour later and then 5 VMs back tomorrow, I want that all done for me automatically. I don't want to have to worry about that, right? And they want to be able to manage it. They want to be able to use their consume it. Especially if you're a developer, you want to be able to consume it through your API. You don't want to have to configure hardware, right? They want to be able to configure it just using some API calls. So programmable, and they don't want to have to worry about fixing things or calling IT to fix things. They want it all fixed automatically for them. So some of you may notice something interesting about this set of definitions for SDDC from a user's perspective. And if it is because it's essentially the definition of a cloud, right? So this is the NIST definition. And if you look, what they define, it basically maps to this. So what am I saying? Am I saying that a cloud is, in fact, a software-defined data center? Not necessarily. What I am saying is the SDDC is the underpinning for a cloud, right? So in essence, and from a user perspective, they don't care about the underpinning at all. All they care about is the outcome. So let's keep that. So you need to, as an IT admin, you keep this in mind. This is what they care about, as opposed to an IT admin person, right? We're the guys who care about stuff like, hey, is everything virtualized, right, rather than physical? You know, we're the ones who may care about, we separate the details of how data planes and control planes are separated, whether you can centrally manage what kind of hardware it's running it on. Is it heterogeneous? Is it commodity? Can I do a declarative configuration instead of having to go through 20 steps? Just say I want this, and have something configured, and have policies apply and self-heal. Most of this stuff, some of it an end user might care about, but most of it you care about, right? So one way to look at software SDDC is that it is what, as an IT admin, is what you need to build in order to deliver this, a cloud-like experience for your end users, where they don't have to care anything about the underlying hardware. They don't have to care that it's SDDC, but they get this outcome. Make sense? So think about that as opposed to just this, as what would make a software-defined data center, right? When you deploy it, is it programmable? Is it self-healing? Is it policy-driven? And when an end user consumes it, does he get all of this for what you build? All right. So quickly, where are we today with SDDC? So I'm going to go through some various vendors and other technology companies that have made claims around SDDC. So we'll start with the big three, public cloud providers, right? So these cloud providers, these three own roughly 70% of the public cloud market, probably more. So AWS alone is bigger than Azure, Google Cloud, and the next 10 public cloud providers combined. So really, these three are the ones we're talking about, right, when we talk about public cloud. And I'm saying that as someone who used to work at Rackspace. So these guys actually are if you listen to them talk, they are the biggest users of SDDC today. And they've been using SDDC for a number of years. So if you want to learn more about how SDDC works at production scale, you should be reading what these guys are doing, right? And what the kind of things they have to do to make it work. So, and they basically offer the best cloud-like or SDDC in the back-end experience for users, right? Because in a cloud, the users don't care about hardware. They don't have to know about hardware. They just have to know the APIs, right? So why are they so successful at building SDDC? Well, there's a couple of common things that if you read what they say. One is that they actually built all their own hardware, or they designed it anyway and then have a white box person build it. So that's very key, right? If you talk to AWS, for example, they've said, we will never, or what they've said is networking vendors, Cisco, for example, and storage vendors constantly pitch their stuff to us, and we can't use it because they can't respond fast enough to our needs, right? Only by building something purpose-built can we actually create that SDDC that they need to respond to the customers at scale. They actually run their own custom software. So all these servers and networks and storage runs firmware that these cloud vendors have created themselves, right? And there are no snowflakes. That's a really important thing, right? If you talk to any of these cloud providers, a server is a configuration, a rack, looks like the same rack everywhere they go, right? There is no one special rack that's configured slightly differently. Every pod, you might say, looks the same, right? And that allows them to have greater control, right? And lets them be able to tune their software, right? Because one of the things, remember I talked about one of the big problems, for example, with software-defined storage is there's so many different types of storage. How do you build the software that can manage all of that, right? But by keeping everything the same, they can build that creates a common data plane that the control plane can easily manage with very little work, right? And they automate everything, right? Because again, one of the propositions of software-defined is everything's programmable, everything is fast, everything's adaptive, right? You can't do that if the bottleneck is Bob over there clicking through a screen, right? Everything has to be automated. And they have something called site reliability engineers whose only focus, these are guys who not only know the hardware, they know the software, they know all the code that runs on it, and they can actually work with the developers to fix things when they break. So all these things are very common. When you look at those three big public cloud providers, they would say are common across all of them that help them to build that SDDC. And that's the VMware. So that's a nice complicated diagram. So I know I've been trashing a little bit VMware, right? But I think hopefully I've been fair to say, look, they have a vision. And they probably have the most complete vision for SDDC. But I would argue they haven't fully delivered on it yet, right? They're moving in that direction, but they're not there yet. For you guys, that may be the one you care about, right? Because unlike the public cloud, they actually let you tune some of the knobs, right? So if one of the propositions of the cloud is you don't actually touch the SDDC, right? That's what the public cloud provider engineers do. With VMware, do you actually get to touch that if you run it on premises, right? It's commodity, hardware-based, and it's built on vSphere, which is both good and bad, right? It's good because you guys are familiar with it. So it's an easier, you guys know how to get your way around vCenter. The problem is, the reality is vSphere was not designed for software-defined because that concept wasn't really quite there yet, right? some people can make an argument that vCenter is the control plane, and then ESX is just the data plane. So there is some separation, but if you guys have worked with it enough, you know it's not always that programmable, right? There are a lot of other things you have to do. So, and I don't blame VMware for it. That concept wasn't there. It wasn't what was needed at the time. And now the challenge they have is they have to retrofit it, right? And they're starting to do that. So one of the talks that you guys probably heard of Frank Denneman. One of the talks that he's giving at VMware is a new project or a new solution that VMware is looking to roll out, which will essentially bring software-defined capabilities into vSphere. So I would kind of take a look at that talk if you guys are going to VMworld. All right, so, but also NSX is the leader, right? They more or less created the market, and they are still the leader in the market. I would argue still the leader in the commercial SDN space, right? And just like with everyone, anyone who tells you to have software-defined storage, there is a work in progress, right? So now, I mentioned before, just having a VMware stack doesn't make it software-defined because it doesn't have that ability to program and to be adaptive. That's where vRealize Suite comes in, right? So to get any semblance of SDDC, you have to know vRealize, I would argue. And that can be a challenge too, because vRealize Suite wasn't designed to be software-defined anything. It was an orchestration tool, and I would argue not a great one, having worked with it. But VMware has done some work with it. It's gotten better. But it's what they've picked, right, to sort of be the control plane for their software-defined data center. So you have to know it. You have to learn it if you want to run SDDC and deliver that experience for your users. And today, one of the reasons I'm going to say that it's not a full-fledged solution yet is it's still a collection of parts, right? It's still a bunch of things that you have to cobble together. Often, you have to get the professional services guys to come in. In a real software-defined data center stack, I would argue that should not happen, that you should not have to cobble and integrate things and write scripts to do all that. That should all be fully baked. And it still doesn't solve some of your cultural problems, right? Because I talked about the fact that you need DevOps mentality, right? That would actually let you program your infrastructure to meet changing demands. All right, so Microsoft, how many of you have heard of this? It's the Microsoft Windows Server software-defined solution. Guess what? They're playing catch-up, right? It's a bunch of, if you look at it, it's essentially a bunch of cobbled together Windows Server-based technologies that built what looks like a Microsoft version of the VMware stack, right? So it has a lot of similar propositions that the VMware stack does, and it has some of the same problems, right? And it's a potential solution. If you have people who are Microsoft experts, maybe even more than VMware, that may be a way to go, right? But again, it has a lot of the same problems. It's not a fully realized SDDC stack. It's still just mainly a bunch of components put together. And then Azure Stack from Microsoft. So think of this as basically it's an extension of the Azure public cloud, right? So you can run, whatever you can run on Azure, you should be able to run on Azure Stack. But it's not designed for your on-premises workloads, right? It's really designed for stuff that you're going to run in Azure anyway, right? And it's actually designed to be a black box. You can't upgrade it, for example. Microsoft will push the updates to that box for you, right? You can't make configuration changes to it that are outside of the guidelines they give, right? Because it has to look like the Azure public cloud. So you have very little control, and it's designed so that a partner would do a lot of the work for you. So some of you guys will go, I don't want that because I don't get that. How's that SDDC for me? Because I don't get to control anything. For the users, this may be the fastest way for them to get that experience because it will be like they were running Azure public cloud, but on inside of your data center. Okay, and then the do-it-yourself model. Some of you may want to try to do that. So I would highly discourage this, right? But if you want to do it, here's some things you should keep in mind, right? It probably works best if you are willing to build your own hardware and software. If you do that, you probably have the highest potential of success if you are capable of doing that and willing to do that. Most of you aren't, right? So you're going to want to deal with, so you're going to probably have to deal with commercial stuff, like the VMware SDDC or the various components and stack that you're putting together yourself. So then at that point, look at all these things you have to do. Basically, you become your own vendor, right? You decide, I don't want to work with a vendor to build the SDDC. I'm just going to buy their parts. Well, now you've become the integrator, the integration vendor for your end users. So you guys are able to do that and willing to do that, then you may be able to do it yourself. You're going to need a team of engineers, right? Because you guys will need to know how to tie all the various components and code together, right? And you're going to need to adopt that similar mindset that you see in the public cloud. So if you can do all those things, I would say go ahead and build it yourself. If you don't, then I would say there's other approaches, right? So some of the recommendations I have, and we're starting to wrap up, is focus on outcome. Again, don't worry so much about, oh, is it running vSphere and NXX and vSAN? Or is it running Hyper-V and storage spaces direct, right? Worry about the outcome. What are you, if you deploy that or built this thing, what are your users going to get out of it, right? Look at the ROI. What's the return on investment? What's the opportunity cost? Does it make more sense for you to build it on your own or to buy it for someone else or to not to worry about it at all, right? If you're a small, medium business, you know what? If you really want that experience, just use the public cloud, to be honest. Your users will get that experience right away, and you don't have to put the work into it, right? If you have to build it, then use what they call a validated stack, right? Something that VMware has as partners with Microsoft, where they put the stack together for you and said, hey, it all works together. There's still a lot of work to actually get it to work in your particular environment, but at least you're kind of halfway there, right? So you could do it that way. If you're a large enterprise and you're going hybrid, so it means you probably go hybrid, I would still say think cloud first, because again, user outcome is more important than what you want to be able to build yourself, right? And then a lot of similar things. And the most important thing, avoid snowflakes. The minute you do a snowflake, you do a bunch of snowflakes, you've killed the whole idea of SDDC, because there's no way you can program that whole environment, right? Automate as much as possible, right? So learn automation. If you guys are still using primarily the GUI to do things, then you're going to have a hard time, to be honest, because you're not going to be able to leverage that separation of control and data plane properly. And day two is more, this is actually another reason why you might want to use the cloud instead, because it's one thing to get things deployed, it's another thing to run that thing a year from now, right? And when changes occur. All right, so a couple of quick things to get started. So I mentioned even if you don't plan to use the public cloud and you really want to build your own SDDC, I would still say familiarize yourself with what the public cloud offers, because that's the experience that your users actually want, right? And focus on the outcomes. So you can start testing maybe what it would be like to run an SDDC for your users and what the kind of things they would want to ask for and want to be able to do. So I don't think I have time for demo. If I'm right, what time is it? Yeah, let me wrap up. So I was actually going to show you, there's actually a thing called CloudFormation in AWS, all the public cloud vendors, something similar, where literally, with a single command, a few APIs, I can build this. An end user can build this themselves with no IT vendor, no IT in the middle, right? If you're a developer, right, this is what you want. You want to be able to do all this in a single command, right? To build, this is essentially a LAMP stack. Web servers and load balancers and databases, and it's all HA. And again, it can all be done with a few simple commands and using a template. So another one, how many of you have heard of VMware Cloud and AWS? Is it possible if you're a VMware customer not to have heard of it, right? So this is the stack. So a few things. This is actually a great way to get started with some caveats. So first of all, they call it SDDC. It's not SDDC, right? It's SDDC only if you're in marketing. And the reason is, when you built this thing out, you get vSphere, you get NSX, and you get vSAN. What you don't get is the control plane for all the whole stack. You don't get vRealize, right? So you just have the VMware stack. You still have to, you would have to connect it to your vRealize environment in your own data center, or install it into AWS, VMware Cloud and AWS. So out of the box, it's definitely not SDDC, despite what it says. Sorry to say. But it's an opportunity for you as a product. So one of the things I hear all the time is customers going, I'm interested in NSX, but I don't have it in my environment. I don't have a way to play with it and to learn about it. Well, now you got a way to play with it, right? Just by deploying this. And it gives you access to AWS services. So you can start seeing what you can actually build for your users that they can take advantage of. And one of the more important, cooler things that's happened in recent months is when it rolled out, you had to start with 4 nodes, which was not cheap, especially if you just wanted to get started. They just recently introduced a single starter edition, single host edition. So you can actually just get a single stack that has NSX, has vSAN, has vSphere. It doesn't have everything you need, but now you can actually play around with the products, get familiar with what it looks like. And it starts showing you some of the capabilities of what you can do with some of the core components of an SDDC. And then the Azure, and also obviously folks like Dell EMC, VMware, they can probably get you something you can use on premises. Right, so there's different ways you can play with things to get used to it, to kind of start playing around and getting familiar with it and test things out. All right, so some closing thoughts. Thank you for sticking around. So hopefully I've been balanced in my presentation. That look, the SDDC has some benefits, but there's also a lot of marketing hype, and it really isn't fully finished and polished, as most of the vendors would like you to believe. Right? You probably got tired of hearing me say this, but to me, this is one of the core things that defines a software-defined data center. Or is it, not only are the individual components, there's separation, but the whole stack should have a separation. I should be able to control that entire stack, compute, storage, and networking, all from a single control plane. Right? If I have to go to 3 different tools, that's not all that software-defined to me as a stack, as a data center. I may have software-defined components within it, but the whole stack itself isn't particularly software-defined. And we're not quite there yet. Right? The public cloud vendors are there, but we're not there yet. The commercial vendors aren't there yet. So, but you guys have the ability to push for that, if that's what you think you want. Right? It should be programmed. So again, it should be programmable. You can't program it. If you can't make changes on the fly, it doesn't really fit the definition of software-defined. Right? Again, integrated stack. I can't say that. Don't build your own if you can avoid it. It's more pain than it's worth. The cloud providers are miles ahead. So even if you don't want to use them for whatever reason, you can't use them, I would still try to learn from them, right? Because they've had many years' experience with this. But if you are going to focus on building your own or having an on-prem solution, Microsoft and VMware probably have the best, are probably ahead of everyone else in terms of trying to prepare the entire stack and not just specific components. Again, back to the public cloud, right? For an outcome. Now, again, not only because that's you usually get the outcome they want, but you can learn what the outcome should look like for your customers when you build a SDDC. So, all right. So, thanks for your time. Unfortunately, I had a demo, but we started a little late, so I couldn't show you. VMware Cloud on AWS is stupid easy to spin up. it took me 5 minutes to start the configuration. Unfortunately, it took 5 hours for it to get provisioned, but still faster than you try to build your own hardware, right? So I would encourage you to try that out. Again, encourage you to get familiar with the public cloud. I'll be around the rest of the day, probably at the Rubrik table if you want to ask questions, if you want to tell me how wrong I am, that's fine too. I'll also be at the Lobster Bake, so feel free to reach out to me, and love to continue to have conversations about what the software-defined data center means. Okay, thanks.